Hello friends. In this lecture we are going to discuss about the array. So what is actually the array is? So in this lectures we will basically focus on why we'll use the array, what is the advantage, what are the different types of the arrays are available, what is their actual applications. So before proceeds to what the actual definitions of the array, we should have to know that why we use this array. So far, whatever the problem that we have solved till date, in that problems we have provided some inputs or we have computed some values. So to whether to providing the inputs or the computed value, whatever the value that is going to be computed, to store it, we need some variables. So in a program, if we provides the integer type of inputs, we must have some variables. Let's have a, and we'll have to specify which kind of the variable it is. So we'll have to specify the variable is the integers, and if you wants to store some value, so you can specify like 10. Suppose 10 is some of the inputs that will be assigned in some of the variables a. Similarly, suppose we need some of the floating type of values for holding the some of the floating type of variables. Also, we need a variables which should be the floating type, and that floating variable can hold the floating type of values. Let's have the 5.5. So in the previous example, whatever we have discussed, where we have seen that to hold some values, we need some variables. But in real world, we face a various situation where instead of having one value or two or three values, sometimes we require 1,000, even more number of values, where those values may be externally supplied by the users or may be computed in the program itself. So we need more number of values rather than this two or three one. So to holding all those values, we need that many number of variables. So to specify that many number of the variables is very difficult job. So the array is a mechanisms who can help us to store thousand number, even more number of values as per our requirement with a single variable. Instead of having declaring more number of variables, array is capable to store more number of elements, one or more number of elements against a single variable name. Okay, now whether all those values are going to store a single memory address locations, basically it is not so. Every elements basically identify a unique index number, and every value will have the separate memory locations. So without wasting the time, let's have actual what is the actual definitions of the array. So if you talk about a array, it is nothing but it is a finite set of data elements finite set of the data elements of similar type or the homogeneous type that stored in contiguous memory location. So what is actually the array is? So array says instead of holding a single values against a variable, array is also provide a variable who is capable to store a finite set of the data element. Definitely it should be the similar type, and that store in contiguous memory location. What is the significance of this contiguous memory locations, that I'll discuss later. But so far the array is a capable to store the finite set of the data element. Definitely it will be the similar type. Suppose in some of the applications or suppose some of the problems, if we have some set of values where some of the values are finite, some of the values are integer type, some of the values are floating type, and if you wish to declare an array who can hold the integer as well as the floating type, this is basically not possible. So if you want to store such state where have a multiple integers and multiple floats, so you'll have to use the two different arrays where the integer array only hold the integer type of the elements, whereas the floating variable or floating array which will store only the floating type of values. So before going towards its syntax and how the basically the initializations can be made, let's have their different types. So basically, the array can be classified into the two broad categories. First, whether it will have the one-dimensional array or it will have the multi-dimensional array. So what is actually one-dimensional array? The one-dimensional array, basically, if you talk about the basic syntax of the one-dimensional, we'll have to define its data type, means we'll have to specify whenever we use some array, we'll have to specify that array are going to store which kind of the values. So if the array has been declared for storing integer type of values, so there must be have some data type that should be integer type. So there should have a data type followed by the name of the array, as well as within this bracket we'll have to specify the size. So what is the actual size it is? So here the size, basically significant of this size, is tells that what is the size of this array of this data type, means it can hold maximum that much of the values. So this size is always be constant value. This should always be constant, and this size means within this bracket whatever the value that will indicates, that is also called as index element. So as I mentioned earlier, that a multiple set of values can share a single variable name, but every values can be identified a unique index number. So this index number basically defined in this within this bracket, and this the size basically specify what is the maximum size of this array. So let's take an example. If we define an array which are the integer type, it means we are going to declare, suppose we want to store some of the integer type of the data element, so we'll have to specify the data type as an integer type. We'll have to specify the name of the array, let's have a, and suppose we want to store maximum 5 number of element, so we can declare an array as a this. So as a definition it's stated, like it is a finite set of the data element. Definitely is a finite because we cannot say any array can hold the infinite number of elements, because infinite does not exist any program. So there should have the finite set of elements. Definitely it is a similar type. So if I declare an array with some of the specific size with the some integer data type, so this array is capable to store only the integer type of the values, not the others one. So once you declare an array, so computer basically occupy the spaces into our computer memory. So as soon as you declare the integer a5, so this variable a are going to hold the 5 integer values, and every values are going to store in this memory block, where the name of the array is a, and this a5, the first index it will be start from the 0, then next index will be 1, next index will be 2, next index will be 3, next index will be 4. So if you define an integer a5, the computers are going to occupy the space into our computer memory for the 5 integer elements. Every elements have some unique index number. So the index number always begin in array with the 0. So 0, 1, 2, 3 and 4. Now why it is called the contiguous memory allocations? It is because of, if we declare an array like integer a5, so if the first element, if we start occupying the space, suppose at the address of 1036, and if the array is integer type, means as we know that every integer element will take the 2 byte of the space, so the next data element, the address, it would be 1038. Similarly the next one it would be 1040, next one it should be 1042, next one it should be 1044. That's why the array says it is a finite set of the data elements of the similar type that stored in contiguous memory location. So it is contiguous form. So if anyhow, if we know the base address of an array, we can easily fetch other elements as well. and this 0 basically called as index. So if we retrieve, suppose the first element, we can easily specify this, the name of the array is A, and I want to index, I want to works, or I want to extract the value of at the 0th index or the first value, so we'll have to specify as a A0. Similarly, if we specify as a of 3, it means we are talking about this element. Is okay? Okay. Now, as such, we can initialize the values in some of normal variables as a two ways, as a compile time and runtime. Similarly, the array can also be initialized as a compile time initializations, as well as the array can also be initialized as a runtime. So as such, we know that at the time of declaring the variables, if you assign some of the values, so such kind of the initialization as a compile time. Similarly, in the case of the array also, at the time of the declaring, if we assign some of the values, so we can such initializations basically call as a compile time initializations. Like, take an example. Suppose if I declare as an integer of a of 5, suppose you are declaring an array A with the integer type and the size is 5, so we can assign the values like 5, like 7, like 2, like 1, and like 9. So here we are assigning the 5 values in this array. So whatever the first element that will specify, that will store at the first index, that is the A of 0. Next element, it will be stored here. Next element will be stored here. Next element will be stored here. Next element will be stored here. Okay. At the time of declaring a array, it is not mandatory also to initialize whole of the array together. It means we are also allowed to initialize the array partially. How it is? Take an example. Suppose the same array, if we initialize like A of 5, we declare suppose an array A of the size 5, we are also allowed to initialize partially. Let's have 5, 7, 2. So instead of, here we have declared the size of the array is 5. Instead, we are assigning only 3 values, the 5, 7, 2. As a result, the 5, it will be stored here, 7 will be stored here, 2 will be stored here, and by default, whatever the rest of the elements will be there, whatever the rest of the spaces will be there, by default, it will be initialized by 0. As we know that if we declare a variables as a locally, so by default it is stored the garbage value, but if we initialize any one of the data element of an array, so rest all the blocks will be initialized by 0. So this way we can initialize a one dimensional array as a compile time, that we have already discussed in previous lecture, but here just we are wrapping up the previous one to that will help us to discuss our the next two dimensional array. So as such, in compile time initializations that we can perform like this. Similarly, the runtime initializations can also be performed in array. As such, in the normal variables to runtime initializations, we have used the scanf of %d of %a. Like here we have to store a integer type of the data element, that's why it is %d, and we'll have to use the scanf. Similarly, for the array, if you need to initialize it as a runtime, we can also use a scanf. Scanf, if it is the array, suppose it is a, suppose you are declaring an array which is integer type, let's have a of 5, and we want to initialize as a compile time, so we'll have to specify it is the %d, because this array is an integer type, and we'll have to store the elements at the array A. Here we have to can specify at the index number that I, and this I we can easily iterate this statement as many size it has. So we can, for the iteration purpose, we can use some loop like for, let's have take a for iteration purpose, we can use the variable let's have I. It will start from the 0 because the array, it will start the index element the 0 and it will continue up to 4. So let's have I less than 5 and I plus plus. So if this statement will specify the scanf will execute the 5 times, as many times at the first time the I will be 0, next time the I will be incremented by 1, it will becomes a of 1, next time it will becomes a of 2, a of 3. So as the users will provide, it will store the values in this block in this fashion. Hope the one dimensional array it is clear, and we have already gone through few lectures in one dimensional array in earlier, as well as we have gone through some of the examples as well. So let's go for the two dimensional array. Two dimensional array. So in the one dimensional array, we have seen that the array basically used to represent as a row vector. Similarly, in real time we will face a various situations where we may have to represent the data elements in the tabular form. In the table, there may consist some rows, there may consist some columns. So whenever we want to represent the data element in these forms where some has some rows and some columns, we can use as a two-dimensional array, because if it is a one dimensional, so it is a single row vector. If it is if we talk about tables, is nothing but the combination of such row vector, so it will create such kind of the table. So that's why we'll have to use the two dimensional array. So here the rows will also start from the index is 0, 1 and 2, and here let's have 0, 1 and 2 and 3. So in this two dimensional array, the number of rows is equals to 3, number of columns is equals to 4. Okay. Now, what is the basic syntax that we'll have to follow for declaring the array? So as such, the one dimensional array, there have some data type. Similarly, in the two dimensional array, we must have to specify at the time of the declarations which kind of the value it is going to be stored, whether it is the integer type, float type or the character type, you must have to specify, followed by the name of that array, as well as we'll have to specify the sizes. Instead of having a single size, they will have a two size, because the two dimensional array where the first size, this size, the first one it will specify for how many number of rows, and the second one will specify how many number of columns. Okay. So in this example, suppose if this tables, if you want to create with the integer type of the element, so we'll have to specify it is the integer type, and let's have the name of this two dimensional array is A. We'll have to specify it is 3, as well as we'll have to column it is the 4. So here this 3 will specify the number of rows and 4 will specify the number of columns. So once we declare an array or the two dimensional array like this, the computer definitely is going to occupy the space into our computer memory. Here the computer basically occupies as a the data element in row major order. So in this example, suppose there have a 12 element. So if it is the array of A, the first element is going to store for the 0th row and the 0th column, second row for the 0th row and the 1th column, the next element for the 0th row and the second column, similarly the next element for the 0th row and the third column, similarly next one it will be 1th row at the 0th column, and so on. So the computer basically occupy the space into our memory. Definitely the memory are going to occupying as a contiguous form in row major order. So it will take the, it will occupy the first row, then next row, then next row, and so on. So if the first element, if it is integer type, suppose it will start at the address of 1036, next one definitely it will be 1038, next one definitely 1040, 1042, 1044, and so on. Now, let's go to the initializations. How can you initialize the two-dimensional array? So, if we talk about the initializations, as the one-dimensional array can be initialized in two ways, compile time as well as runtime. Similarly, the two-dimensional array can also be initialized as a compile time and runtime. So if you talk about the compile time initializations, so here, as we have seen in the one-dimensional array, that during the declarations of your array, we can initialize it. Similarly, in the two-dimensional array, at the time of the declarations, let's have, for the simplicity, let's have the number of rows is 2 and number of columns is 3. We can initialize this array. So there have 2 and 3, so there have total 2 rows and 3 columns. So the number of elements definitely is 2 into 3, 6 element. So we can initialize the array by specifying what should be in the first row and what should be the element in the second row. Like if we want to specify the 3 elements in the first row, let's have 5, 3, 7, it is in the first row. And for the second row, it will, let's have 9, let's have 7, let's have 6. So in this way, we can initialize this two-dimensional array. In the other way, it is also not mandatory that you'll have to specify as row wise what are the data element are going to be stored. Instead, you can also initialize this two-dimensional array in continuous set of data like 5, like 3, like 7, like 9, like 7, like 6, like this person also, it is okay. So here the first element 5, it will be stored here, 3 will be stored here, 7 will be stored here. So if it is 2, 3, so if 2, 3, 3 number of elements in the first row, next 3 elements for the second row. As in the one-dimensional array, we have seen that the array can be initialized partially. Similarly, in the two-dimensional array, the array can also be initialized partially. Like integers, suppose a, 2 and 3. If you wish, then you can also initialize the elements like 5, let's have is 3, let's have close it. And for the second row, let's have 3, let's have 9, let's have 2. So it is also allowed. So if you do like this, so it will total there have a 2 rows, 0th row and 1th row, and they'll have a 3 columns, 0, 1, 2. So there have a 5 will be stored here, 3 will be stored here, 3 will be stored here, 9 will be stored here, and 2 will be stored here, and rest of the spaces by default it will be stored as a 0. Now, at the time of the declarations of the two-dimensional array, the size of the row, it is also optional. It is not mandatory, but the size of the columns you must have to specify, means it is mandatory. So if you wish, you can also declare an array like integers a. Do not need to specify that how many number of rows, but at the time of the initializations, the computer by default it will assign how many number of rows. Like if you specify like 5, 3, 7 in first row, let's have 9, 7, 6 in the second row, let's have 3, 9, 4 in the third row, like this. So the computer by default it will understand they will have 3 rows. Is it fine? So this row, it is optional. Size, to declaring this size of the row is optional, but whereas this one is mandatory. It's fine. As the compile time initialization has been performed two-dimensional array, similarly the runtime initialization is also being performed. How the runtime initializations can be performed? As such, we know that for taking the inputs from the users, we'll have to use as a, that is called as a runtime initializations, we can use as a scanf. So scanf here to takes the input, if the two-dimensional as the integer type, we'll have to specify as a %d, then we'll have to specify that ampersands, and here instead of having a single subscript or single index, we'll have to specify the 2 index. The first index we'll have to specify for which row, that is the ith row, and which column, that is the jth column. So for initializing this bus, here we need the 2 loops instead of 1, because here we are using the 2 variables for defining the row and defining the column. So here we'll have to define that how many number of the rows. So if I declare suppose an array integer a of 3 4, so we'll have to specify I, it will start from the 0th index and it will continue till less than 4 and sorry less than 3, sorry, and I plus plus, and at each row how many number of the columns. So they have a total 4 columns. So we'll have to specify j less than 4 and j plus plus. So this way we can initialize the two-dimensional array as a runtime. Hope you have understood this two-dimensional array, the how the two-dimensional array can be defined, what is the role of one-dimensional array, what is the role of the two-dimensional array, how it can be initialized, whether it is compile time and runtime. And the next class we are going to discuss some examples from the two-dimensional array. Basically, one of the applications of the two-dimensional array, it is nothing but a matrix that we are familiar with in the mathematics matrix. So as such, we know that the matrix can be represented as a row as well as the columns. So as many number of the operations that we can perform in the mathematics in the matrix forms, like transpose of a matrix, additions of a two matrix, or multiplications of a matrix, or to check whether the orthogonal matrix or not. So those problems can also be solved through this two-dimensional array. So on the next class we are going to discuss some problems related to the matrix in under the two-dimensional array. Thank you. Thank you for your watching.